Welcome everyone to this new tutorial. Today we're going to properly start to develop the game. Hopefully you watched the first tutorial, and if you did, let's get started. First thing I'm going to do is just create a new project. I'm going to select an empty project. I'm going to call this my first C++ game. I'm going to choose a location, and let's create. So at this point, as you saw in the last time we did a simple test project, we can start creating the files for our project. If you recall last tutorial, you remember that we can separate the game into a platform-dependent layer and a platform-independent layer. So the first file I'll create will be called Win32 platform. So this file will hold all the platform-specific code for the Windows platform layer. And just like last time, I'm going to create the application entry point. But this time, it won't be int main. Since we're doing a graphical application, we have to call a specific entry point called winmain on Windows. And I'm going to search the documentation for that by typing winmain msdn. MSDN stands for Microsoft Developer Network. It's where all the documentation for the Win32 API is located. So let's check it out. So this is the entry point for a graphical Windows-based application. Let's call that. And we also have to include the Windows library. Then remove this specification from the declaration. That's not necessary. We're going to organize all the parameters. Okay, let's try compiling. So we got a compiler error. Problem is, in the default setting in the project that we created, we're going to create a console app. And a console app has a different entry point than a graphical app. But since we do want to create a graphical app, I'm going to change what subsystem this app should use. So I'm going to right-click on the project and select Properties. From here, I can go to the linker and System. See how it says that we are supposed to be using the console subsystem? We want to change that to Windows, but there's a problem. If you see up here, our configuration and platform is only set to the active one. What does that mean? Well, our project can be built for several different platforms, as well as use different configurations. It is very common for at least two configurations, a debug or development and a release one. Debug is supposed to compile a little bit faster and also give us a lot more information about the program, so we can know which problems happen when they do happen. The problem is, since it's giving all that information to us, it's going to run much slower than the release one. So we usually want to test the game on the debug build, but build it to the final user using the release configuration. Since the game is going to use a window on all platforms, I'm going to change from active to all configurations. Same thing for the platform. Now I can change the console to window. Now let's try compiling the game. Now we successfully compiled the game, and we can even change the target platform. For instance, if I set the game to run on release and try to run again, everything works fine, as well as the target platform. We can change the game to run at 64-bit OS, and it works just the same. Now, since it will be a small game, we could build it to a 32-bit OS. There's no problem. We're going to go back to the debugging mode. And now we can write the program, right? Because it's empty. So the first thing we want to do is to show a window so we can draw on that. In order to draw a window on Windows, we need three things. We need to create a window class, register it, and then call create window. So let's create the window class. Again, we can go to the documentation so we know exactly what we need to fill on that struct. As you can see, there are a lot of fields on this struct, but we are only interested in the style, the window callback, and the class name. So let's create a window class. And it's going to start out empty. For the style, I'm going to set it to H redraw and V redraw. This will make sure that we will redraw the window horizontally and vertically whenever we need to. As for the class name, we just need a string to identify our window class. This will not be visible to the normal user. And now the window callback function. This callback function is the way that Windows use to pass messages down to us. So whenever something important happens to the window, like receives user input, or is closed, or changes the size, or is minimized, or is active or inactive, we'll receive a message through this callback function. And this callback function needs to be specified according to the documentation. So if I click here on this link, I'll be able to see what the callback function must look like. But I'm going to call it window callback. By passing that function pointer here, Windows will be able to call it whenever it needs to send us a message. Let me just organize it here. Okay, let's try compiling. Okay, it failed because Windows callback must return a value. Because we are expected to process these messages, we could call dev window proc and pass all the parameters that we received and return the result. Okay, so we compiled successfully. So whenever a message is dispatched to us, we're going to do the default behavior. Now let's register the class. To go to the documentation, all it needs is the pointer to the window class. I'm going to talk a little bit about pointers, in case you're not 100% familiar with them. Imagine that the memory we have at our disposal has a series of lockers. Each locker has a number that identifies it, and whenever we create a new variable, something is stored inside a locker. Some lockers are bigger than others, because some variables are larger than others. When we create a pointer variable, instead of storing the actual value we have inside the locker, for example, 6 in this case, we are storing the number of the locker that the value is stored in. So whenever we pass a pointer around to a function, like we're going to do in this case, we are passing some information that the function can use to go to the specific locker we are storing in our window class and read it or even change it. Another important point, even though the variable can be huge, its address, which means that its identifier number, will always be of the same size, which is 32 bits when you're compiling for a 32-bit platform and 64 bits when you're compiling for the 64-bit platform. So when we created the window class, we got a locker and we filled that with some information we needed. Now whenever we're going to pass a pointer to the register class, we're going to pass the number of the locker or the address of the variable. That's it. So let's do this. Okay, let's try compiling. Perfect. Now we can finally create the window. If I search for the documentation, you can see what parameter it takes. Just a quick note, this A stands for ANSI characters, which means that the characters we're going to use for the class name and window name doesn't have special characters. If we delete that, the Windows will decide the best call for us, ANSI or wide. So we have to pass the class name here. We can either type it again, or we can pass that variable we just created. The window name will be the title that will be displayed on top of the window. Let's call this my first game. The style specifies how the window will look like. Here in the documentation, you can see there are several options that we can use to make the window look exactly how we want to. Later on, we're going to do like a full screen window, so it doesn't matter much. But for now, let's do overlapped window. Invisible. That's pretty important. The X and Y is where the window will be spawned in the player screen. We can pass CW use default for the windows we created where it thinks it's best. The width and the height, we're going to do a full screen window later, but for now I'm going to do like 1280 by 720. Let's see. Window parent and menu, we don't really care. The instance, we're going to pass the variable that we received in the entry point. And the last one we don't care either. Let's see. Did you see that? A window just popped up. So we are successfully creating a window for the game. There's a problem, right? The window just disappears when it finishes. Let's go line by line on our game and see exactly what happens. So first we create a window class, and we can open a watch window on debug Windows watch. I'm going to pop it here in the side. And if we type the name of the variable window class, we can see the values that we filled. Then we registered, then we create the window. Here's our window. But when we end the program, it exits. Remember last tutorial when we talked about the game loop? Well, that's what we need right now. We need to be looping the game for as long as it's running and do the three things we discussed, which is gather input, simulate the game, and render the game. So now I'm going to create a variable that will tell us whether the game should be running or not. We're going to call it running. And its default will be true. So now we're going to do these things forever, basically, or until the user tells to stop the game. Well, how does he do that? If he tries pressing the X button of our window, we will receive a message that the window tried to be closed. So we need to process that message. Remember where we're going to do this? Here in our window callback. We can switch on the message and test if it's a window close or a window destroy message. If that's the case, we can set running to false. And we're only going to do the default window procedure if we didn't handle it ourselves. I'm going to create a result variable. And pass it whatever Windows wants. However, there's still something else to do. In this case, we're going to be running pretty much nothing forever. So we have to ask Windows if there was any messages for us. That's the first part of our input. If you create a message struct and call peek message in a while loop, it'll get all the messages that we didn't read so far and give us a chance to process it. So it takes a pointer to the message, it takes a window, so we need to save it here. The filters I don't really care, so I'm going to pass 0 for the min and max filter. And for the flags, I'm going to ask it to remove the message. So we only read each message once. If you want to know more about peek message, you can search that on documentation like we did for the other functions. For now, all we want to do is to dispatch that message to our callback. I'm going to call translate message and pass the message, and dispatch message and also pass the message. So now if I try to run, the window will stay up and we can move it around because the message for the movement and the mouse is being passed to our callback and doing the default behavior. We can also make it full screen, minimize it, change the size, and close it. And our game exits. That's perfect. So now that we have a window, we can start drawing to it. And that's what we'll do in the next tutorial. I hope you liked this video. If you did, press the thumbs up and share with your friends. It helps a lot. Maybe comment down here what you like the most or something that you had a hard time with. So that's it. I hope to see you in the next tutorial. Bye.